Questions, anyone?
I was just curious about when you see those objects, when they are visible before they cut out and reappear. Can you comment on what the absolute brightness of those things are? Are they all about the same?
So I could show, here, let me put a backup slide here. So this is comparing the brightness of M51DS1 with Betelgeuse. So you can see the red points are M51DS1, and it disappears and then reappears here. And there's Betelgeuse. So you can see this is a, what, -7 absolute magnitude in F8.4. And that's about in line with what we expect for other supergiants, which are these yellow points here in the background.
Thanks. I have some thoughts on that.
So I'm curious, what are your thoughts on wavelengths like X-rays or radio in the study of these objects, particularly to distinguish between the accretion scenario or the merger scenario?
So I think for the situation where you have a shrouded star, radio observations might be able to determine if you have something like that. But I believe you would also see the accretion in radio as well. As far as X-ray, I don't think we have high enough resolution to observe, accretion onto a black hole. If of course, if they're in a binary, then maybe we would see that. But those sources would probably be known already.
So this question is kind of in the spirit of, let's take your difficult search and come at it with an even more difficult search. So take it in that spirit. But there's now a good predictions about multi-messenger detections from failed supernovae, like gravitational wave emission, that might be an extra way to kind of beat down some of your backgrounds here. So have you, maybe we're not ready to do that for a few years, but have you been thinking about how that might work 5 years from now, 10 years from now?
I think 5 years from now is incredibly optimistic. Based off of, or 04 currently, I think it's unlike, again, if these are in binaries, we are seeing some of these low mass objects in LIGO. So we know that these black holes exist, and this is an enticing way to create them. However, I think unless it's in the nearby universe, it's very unlikely that you'd be able to see a gravitational wave, so when I say nearby universe, I mean like our Milky Way, to see the gravitational wave from this direct collapse. Maybe in, the end of my scientific career, we'll have strong enough gravitational wave detectors to do that. But I think 5 years is unrealistic.
All right, let's thank Genevieve again.